Alright, hello everyone, welcome back to the channel. Today we're gonna keep looking at this new add-on called BioBlender. So let's go ahead and open Blender through our command line terminal. Now that we're here, again press N for our N panel, and BioBlender we should have our add-on. So today we were gonna look out at the workflow of incorporating membranes and proteins. So the first thing we're gonna do is pick our membrane protein that we want to scatter on our membrane. So in this case, let's go to 3D9S. That's gonna be ubiquitin. So we're gonna go ahead and import ubiquitin into our scene. All right. So once we imported ubiquitin into our scene, we see that it is a little it's rotated. So we're gonna head and fix that before we keep going. So we're just gonna fix the rotation on this axis. Okay. Give it a little bit more there. Then on this axis is fine, and then we look at from the top, and then we're just gonna change this slightly. All right, so now we're gonna go ahead and apply that rotation. All right, so now that we have our protein into our scene, we're gonna go ahead and import a planar membrane, and then the next thing to do is that we're gonna generate a collection, and we're gonna call it proteins. Once we have our collection proteins, we're gonna put our protein 3D9S into that collection, and once we've done that, we can go ahead and hit scatter on the object we selected, and as we see, we get protein scatter in our plane. Again, if we select that object, we can change the cross section of it, so I can go to a value of 0, and then again, if I select the membrane, I can go to a value of 0, and then I have that region of my membrane. I can maybe make it larger in Y by 2, and I can again select my other emitter object and change the scale of it. Other thing that I can do is let me go ahead and delete that emitter, and let's go back to the regular scale and the regular cross section. So now what I'm gonna change is that instead of naming it 3D9S, I'm gonna have 3D9S, but I'm gonna put main underscore main. What that's gonna do, it's gonna bring our protein, but in this case we're gonna get no overlap. So the first one, it's gonna be completely random the way it gets distributed. This one, if I hit scatter, it's basically using that Blender Poisson distribution that it's coded in geometry nodes to basically have no overlap. So if we go to the settings here into the modifiers, then we can change that distance. So if we make the distance larger, then that's the distance of each of the copies. If we make it 0, then we do see some overlap. But if we keep it like at something around 0.5, and then we can increase the density, then we get this protein distributed this way. One thing that we can also do, and let's try that on a vesicle first. So let me go ahead and delete these two objects, and now let's change to a vesicle. Again, since we already have our collection, all we have to do is press scatter on this new emitter, or on this new membrane, and here we can again go back and play around with our settings here. So we go again like a distance of 0.5, and maybe we get a little more density, so in around 10. So we get this nice distribution of proteins around our membrane. Now you've probably noticed that we get this overlap. The reason for this is that ubiquitin is around the size of the thickness of our membrane. So one way to get rid of this is if we select our membrane emitter, and then if we press holes here, what that's going to do, it's going to generate a hole. It's going to basically create a mesh and paint, use vertex paint to create a mask wherever we see that protein. So as we see now, the difference is that now we've created holes. So if I hide that protein emitter, now I do see my membrane again, but now it has holes instead of now it has holes where the proteins should reside in. These holes, it's still a work in progress. In this case, there's still some cases in which it fails. The reason for so for that reason, I've included these fast holes, and fast holes usually works. It's really fast, and then but it requires symmetric proteins. So as we see, this protein is pretty symmetric, and they have to be symmetric in the z-axis. Um, the reason for that is because it's not trivial to calculate the radius of the hole if the protein is asymmetric in the z-axis. Um, but if it is asymmetric in the z-axis, then you can still do this, but you have to, it will take more time to compute, and you would have to deselect fast holes. And then the other problem is when you have a lot of overlap of your proteins, then fast holes or even holes might fail. So that's still a little experimental, and it's a work in progress. But for now, for symmetric proteins, it works really well. And even asymmetric proteins, if you have fast holes deselected, it's also gonna work really good. All right. So for now, let me go back, get my protein back in here, and then again I can play around with the materials. I can select the protein. Maybe again go to a real material as we've done in previous videos, and that I committed a mistake because I'm trying to apply it to the emitter, but I should apply it over here. So if I apply it over here, it's gonna show in every single one of my proteins around my membrane. And now the cool thing about this way of doing it is that now that we have holes, we can look at those cross sections. Maybe let's first increase the density. So now if we go to 5000 density in the lipids, and now we play with the cross section, we set it to 0, which is always half, and select our protein emitter and also select that to 0. So we got lucky and we got one of these proteins over here. And as you see, there's still some lipids that we see, but the reason those lipids are there is because the cross sections don't match in this case. So as we see, this cross section, and we can actually improve this a little bit if we increase the number of subdivisions for our emitter. That way we get more of a straight line here. So increasing that number. So now we do see that this cross section is more of a straight line. But still, to have like see our protein properly, although it already looks pretty good there, what we can do is increase maybe the membrane cross section a little bit more. The other way. So if we go the other way, then now as you see there, basically those lipids that remain there are lipids that are very close to the borders. So but if we go there, then we have that cross section, and again we now get no interception. Even inside, if we look inside, we get no intersection of those lipids with our protein. Alright, so let me go ahead and delete this case real quick, and then the reason, let me explain you now why the reason I created this protein collection. The reason for that is that we're able to scatter all sorts of proteins in our membranes. How many? As many as we want if we have them inside this protein collection. And then the reason for this is that then we're gonna have setting for each of our proteins, and then for each of our proteins, then we can control the density of each. If we want more of this or less of that, we can control. Yeah, we can basically control the density. So as you've seen, I imported a new protein into the scene. This is a spike protein for coronavirus. It took a little bit because it's one that has a lot of geometry. If you look at the geometry, there's lots of vertices in this mesh. But again, we can bring a vesicle into the scene, and now all we have to do is make sure we don't have this protein emitter in our so we can move this again to emitters, and now we should only have proteins here or whatever we want to scatter. So let me go ahead and hit main again, so we get that nice distribution. We select here, we do a scatter again, and then we should get now both of our proteins in here. Now there should not be any overlap between proteins of the same type, but if we do have overlap between proteins of different type, then we can always select it, and then as we see here, we get settings for both of them based on the order we found them in our collection. So here I can have a density of 0, and that's gonna turn off aquaporin, and then if I have a density of 0 here, that turns off my spike protein, but I can turn those back again, both of them, 5 and 5. Maybe I want more spacing between my or less spacing between my aquaporin, so I can select like oh, not 0, 0 is too little. no, in fact, let me modify it's the density. So maybe I want to have lots of aquaporing in my scene, and then I want to play with the overlap. So to do that, I can play with this seed here. So this is basically gonna modify that distribution around our protein. And once I'm happy with a distribution, then I can set my camera, go to render view. Let's apply a material to this protein here. Let's change the color. So for that, we go to the material, and we just hit on this number 3 to make it an individual material, and then maybe we can do something like close to red, and then there you go. Now you have this protein scatter onto a vesicle membrane. We could also play with the shape, so let's do that real quick. We can again maybe make it 2 on the y-axis, and then we just have to do that here as well. And now we have more of an oval shape, but however the scatter is still working. And then we can now play with the cross section, have it a cross section of 0, sorry, and then something similar to this. So now we have like this oval shape. So maybe in order to look at this cross section, maybe I also wanna make it oval in this direction, not by that much, maybe like 1.2 and something similar here. 1.2. So basically that. Yeah. So now we can go again back to render view. And as we see here, now we got our so one of these aquaporing seems to be very inserted into our membrane. The reason for that is that probably the origin shifted. So let me see, or maybe we have different dimensions. Yeah, so if we want to pull up aquaporing a little bit, we can go here. Oh no, actually the dimensions are different. So I have 1.2 here, and I have 1.5. So that's basically that problem there. So I go back to 1.5. Oh yeah, and now everything gets pushed to the right place. So now I can take a look on the inside, and then this is what it would look. I can again increase the density of my membrane emitter once I figure all the other settings and I'm good with the way it looks. Then I can increase this number to 5,000 or even 10,000 to get as many lipids, so it looks like a dense phospholipid bilayer. Yeah, we can also look at it from this angle. So from the outside, this is how it would look. And yeah, and that's basically how you combine importing proteins and membranes. In the next one, we will go a little more in detail regarding this, and then we will also look into viruses.